Hello students, AI Unit-3. Previous video, I will start the resolution topic. In this topic, the first algorithm, convert to class form, is completed. Now today, I will start the next algorithm, propositional resolution. Okay, in this algorithm, 3 steps are given. First step is convert all the propositions of F to class form. First, we can convert all the propositions, means all the equations which are given of function f. We can convert these functions into class form. Okay. If the first step is completed, we can start the second step. Negate p, convert the result to class form and it to the set of classes obtained in step 1. Now we can negate the p, means we can remove the p, and we can convert the result to class form. So here we can add the set of classes which are made in the first step. Okay. Now if the second step is completed, we can start the third step. Repeat until either a contradiction is found or no progress can be made. We can repeat this process until no progress can be made. We can make the progress and we can get the result. Okay, so in the third step, there are 3 sub steps are given. First is select 2 classes. We can select 2 different classes. Okay, and then we can call this the parent class. We can select any 2 classes and they are known as parent classes. So second step is resolve them together, means we can solve the 2 steps. The resulting class called the resolvent will be the disjunction of all of the literals of both of the parent classes. Here we can select the 2 classes first and it is known as parent classes. Okay, now we can solve that classes together and we can get the results. Now if there are any pairs of literals L and not L such that one of the parent classes contain L and the other contains not L, then select one such pair and eliminate both L and not L from the resolvent. Okay, so here we can start with any pairs and we can take the literals L or not L and we can take that literals parents and there contains the capital L or not L, then select one such pair and we can eliminate the both L and not L. Okay, now the third part of step number 3 is given. If the resolvent is the empty class, then a contradiction has been found. Now we can solve the empty class. Then we can find out the another possibilities. Okay, if it is not, then add it to the set of classes available to the procedure. Now if it is not possible, then we can add the different set of classes which are available, and we can make the procedure for that classes. Okay, so here the algorithm for propositional resolution is completed. In this algorithm, total 3 steps are given, and we can follow one by one all steps and get the results. Okay, now next algorithm is the unification algorithm. In this algorithm, there is no steps are present. In propositional logic, it is easy to determine that two literals cannot both be true at the same time. We all are know that if two literals are given, so there is no possibility both literals are true at the same time. Okay, at one time one literal is true, and at another time next literal will be true. Simply look for L and not L. In predicate logic, this matching process is more complicated since the arguments of the predicates must be considered. So here we can look the two literals L and not L in predicate logic. Okay, then we can match the process and we can find out the arguments. Now we can take one example. For example, man whose name is Son and not man whose name is Zone is contradiction. So man Zone and not man Spot is not. These two sentences are different, man and not man. Okay, John is a man and John is not man. So we can make the two different sentences, and at the same time not two sentences are true. Okay, thus in order to determine contradictions, we need a matching procedure that compares two literals and discovers whether there exists a set of substitutions that makes them identical. So here we can determine the contradiction of only one sentence, and then we can match the procedure. Okay, and we can compare the two literals and discover whether there exists a set of substitutions, and we can take as a identical. That is a straightforward recursive procedure called the unification algorithm that does it. So here the straightforward means straight procedure is given, and it is known as unification algorithm. Okay, so in this algorithm a basic procedure is given. There is no steps are given in the unification algorithm. Okay, now our next algorithm is for unify L1, L2. In this algorithm, total 6 different steps are given. We can start with the first step. If L1 and L2 are both variables or constraints, then we can take the two different constants or two different variables which names are L1 and L2. Now if we can take two variables, then we can follow the 4 sub steps If L1 and L2 are identical, then we can return the nil. If both L1 and L2 are identical, then we can write as a null. Then second B, else if L1 is a variable, then if L1 occurs in L2, then return fail, else return L2 divided by L1. So here L1 is a variable, then we can say that if L2 is fail, then we can return L2 divided by L1. C, substep else if L2 is variable, then L2 occurs in L1, then return fail, else return L1 divided by L2, else return fail. So in the first step, if L1 and L2 are both variables or constants, then we can follow these 4 different steps. Okay, now second step, if the initial predicate symbols in L1 and L2 are not identical, then return fail. In initial predicates means in the starting imagination, we can use the 2 different symbols which name are L1 and L2, and then we can return as a fail. Okay, this is our second step. Our third step is if L1 and L2 have a different number of arguments, then return fail. L1 and L2 are suppose 2 different variables and they have different number of arguments. Okay, then we can return as a fail. Now in the fourth step, set of substitution to null. This is the short form of substitution. Okay, at the end of this procedure, substitution will contain all the substitutions used to unify L1 and L2. We can take the all substitutions which are present in L1 and L2. Okay, this is our fourth step. Now our fifth step is for 1 to I, 2 number of arguments in L1. We can take the argument of L1. L1 is a variable and we can take as 1 to I. Okay, now 3 possibilities are given in this step number 5. Call Unify with the ith argument of L1 and the ith argument of L2 and putting the result into S. Okay, now second is if S contains fail, then return fail. Then if S is not equal to nil, means some variables are present in S, so we can apply S to the remainder of both L1 and L2, and then we can make the equation like this: substitution is equal to append S comma substitution subset. Okay, and last we can return the subset. Okay, so here our algorithm of unify L1 comma L2 is completed. Now I will revise the topics which are completed in today's video lecture. Today I will start the algorithm for convert to class form. Okay, in this algorithm 1 to 9 different steps are given. Second algorithm is for propositional resolution. Okay, in this algorithm 1 to 3 basic steps are given. Now the third, the unification algorithm is given. In this algorithm the basic procedure is given, not any steps are present. And fourth is algorithm for unify L1 comma L2. In this algorithm, 1 to 6 different steps are given, and we can take L1 and L2 as a variables or constants. Okay. Now, in the next video lecture, I will start the topic resolution in predicate logic. Its algorithm and its example I will explain in the next video lecture. Okay. Thank you.